So, hello. My name is Jordi Cenzano. Just a little bit about me. I'm a software engineer at Meta. And I started in the media space about more than 30 years ago. So yeah, I'm old. And I started in the broadcast world. So I worked several years there, and then I transitioned to the online world. And at Meta, I joined 6 years ago in the Media Foundation org. And I started helping on the reliability aspect and quality of the premium live streaming. And then we expanded those techniques that we developed to UGC live streaming. And the last probably 2 years, year and a half, 2 years, I've been helping to just enable our processing pipelines and adding AI into our media processing pipelines. So, and this is what I'm going to talk about. So stop about me and more about AI video stylization. So what is that? So let me try to answer this question, but from a user point of view. So how the user can enjoy this feature. So this feature is already deployed in US and several other countries. So you can all enjoy it. So if you download our Edits app, there is a video editor. You can just open the Edits app, create a project, go to Gallery, select any video that you want. In this case, I'm going to select this one. Okay, it's a video editor, so you have the timeline. My name is Jordi Cenzano, and I'm recording this video to demonstrate how the stylization pipeline works. Okay. That's it. So now you just need to tap on the video, select the video stylization effect, and you have to choose what style do you want to apply. So let's burn the Meta Office. And just wait 60 seconds. I edited this video. And now you have the Meta Office on flames. Hello, my name is Jordi Cenzano, and I'm recording this video to demonstrate how the stylization pipeline works. Let's see. So this is how easy our users can interact with this feature. And this is not only available in Edits app, it's also available on the Meta AI app. And if you want to try it out, but you don't want to install any app, it's also available on the Meta AI website. And by the way, the three surfaces, they are powered by the same backend that I'm going to explain. So what is really happening behind the scenes? So, but first of all, before going into details, this is an engineering company. I want to acknowledge and thank the whole team, the huge team that of really smart engineers that built this feature. From the model engineers, the Meta Foundation, all the teams inside Meta Foundation org, AIG, and so on. So there is a lot. Probably, if I say more than 100 engineers, I'm not lying. So. Now let's get into the details. So let me start by zooming out and see and take a quick look to the whole pipeline. So what is happening from the moment that you create the video and you decide to apply that effect? So then you are in Meta AI app, for instance, you decide to apply this fire effect. That video gets uploaded into a distributed storage that we build that it's called Oiled. There are papers out there about that. Then there is a data that is sent from the cell phone to the data model, say, hey, we need to apply the fire effect into this video. Then this gets into a queue, hopefully for a few milliseconds. And finally, that command gets picked up by a server with a proper model loaded and warmed up. This server downloads the video from Oil, applies the stylization, and sends back the video to the storage. And now we have the stylized video ready for delivery. And the moment that we want to deliver to the same user or to other users, so we deliver that via our CDN and our delivery system. So for the ones, so probably most of you are super familiar with VOD processing pipelines. And this looks like that, a VOD processing pipeline. And it looks like that because it is that. So we are basically leveraged. So in Media Foundation, long before I joined Meta, we have been processing millions and millions of, Michael will give us some more accurate numbers, but millions and millions of videos daily. So basically we had to build really battle-proven systems to handle all that scale. So what we did is we did not reinvent the wheel, and we leveraged all of those systems. So we had to tweak and modify some of those to adapt it to the AI workflows, to AI processing workflows. But mostly the main change that we did is that when that server that I said with the model loaded picked up the original and transformed it into the stylized, that server needs to have the model loaded and warmed up. And that, for a model like the one that we're using here, it takes several minutes to load. So basically, we cannot load it at every request like we would do in a typical media transformation, like encoding. So we have to have that server ready to serve that request. And this is the main architectural change that we had to build. The rest, we leverage the rest of building blocks of our media processing pipelines. So, but what is that model, that magic thing that you send a video and returns this video and a command and a prompt, and it sends back the stylized video? So that model is called Moviegen. So we published a paper about that. So it's a very, very, very interesting paper. I strongly recommend you to read it. It's quite long, but very interesting. And that explains all the details inside that model. But I'm not an ML engineer, and I'm not going to get into the details of the model. But that model, so basically, as I said, you provide a video and a prompt, and it gives you a video back. But this is not only what we had to do to provide that experience at scale. We had to do much more stuff. Let's get into those details. So that model needs some adaptation, so you can upload a video, any video from any device, and if you send it to that model, bad things are going to happen. So you need some pre-processing. And then when that model outputs the stylized video, you also need to do some post-processing to adapt that and deliver that to our users to the quality that we want. And there is also some data that passes through, but we will get into those details. So let's zoom into the pre-processing. So basically, this is the summary of specs of an iPhone recorded video. So it could be a 4K, 916 with a display matrix rotation of 90 degrees. The iPhone uses it. Variable frame rate estimated at 5997, and blah, 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 and HDR. But if we send that to the model, so we're going to crash it. Because the model expects an RGB 24, some specific resolution. If you read the paper, that paper tells you a lot of details. 24, a specific constant frame rate, 256, not one, not less, 256 frames, and SDR. So you can send it 128, but anyway, this is a simplification. So basically, what we had, and this gets even worse, because I just put a specs from a recorded video from iPhone. But remember, we do have 3.4, if I'm not mistaken, billion users. So those users upload things from everywhere, from the browser, from an app, from an old Android, from our newest iPhone. So the source could be anything, but the output needs to be that. So this is, again, for a media engineer like us, is not rocket science. So we needed to build a processing pipeline, the max, the codes, apply some frames per second correction. It trims or pads in the temporal space. It applies some conditional color tone mapping, and it applies some quite peculiar resize, because we cannot alter the aspect ratio, but we need to give the model the pixels that it needs. So basically, we need to do some mirroring and some smart things there. Again, not rocket science. So, and finally, we extract the audio into the max step. So now let's take a look at the post-processing. What is happening there? So basically, the opposite. So the model outputs the same specs as inputs, and then we basically do the inverse thing that we did on the pre-processing pipeline, and we could deliver that, and that would work. But if we deliver that, probably in some cases, we will not be delivering a good quality to our users. So we should try harder to deliver a good quality. So we basically conditionally added some super resolution model, again, AI again, that increases the resolution that Moviegen provides. Again, conditionally, we also apply some video frame interpolation based on another AI model that produces a smoother content. And again, conditionally, we provide lip sync. So there are some presets in some cases where there is a face, a talking face with some presets that we realize the lip sync does not perform very well on the lip sync. So we added a lip sync model that corrects that conditional into all of those conditions that I mentioned, that corrects that, that lip sync. But it's not that easy. Because if we send the audio, original audio, to that lip sync, the lips are going to go like crazy. So we need to clean, remove all the noise, all the music if there is in the background, and send to that lip sync model a clean voice in order to produce a good lip sync movement. Okay, so this is the post-processing pipeline with the quality enhancements. Again, those are conditional to every use case or every product. And yeah, and this is so basically what we are delivering. So at 1080p, 60 frames per second, less than, we have a limit of 10 seconds of generation. So basically that's why it puts less than 1600 frames SDR and without rotating. So safety. So this is not always, this is not all things that are happening in the when you do video stylization. At Meta, we take really, really seriously the safety of our products. And we spend a lot of time just making sure that those are safe to our users. So we basically, in parallel to avoid increasing latency, when you send us a video to stylize, we trigger an integrity check that makes sure that that video there is no harmful content. If that integrity check does not pass, so obviously we kill the job. And the output, since the model, it's an AI model that creates content, the model can hallucinate too. So we are basically triggering another output integrity check that makes sure that what the model is outputting, it's safe to deliver to our users. If those checks passes, then we deliver the content to our users. And this is not everything. We also add more stuff. So in the encoding and maxing stages, we also add invisible watermarking metadata. So we want to be able to detect that this is a content that it's AI generated. So we can put data in the maxer. We are already doing that. But if that content gets remaxed or gets transcoded, that data is lost. So basically, we add an invisible watermarking that is resilient to cropping, resizes, re-encoding, to make sure that we are able to identify that this is AI-generated content. And we obviously add an overlay that says that, hey, that is a visual overlay that says that it's AI-generated. And as I said, in the maxer, we also add provenance metadata in the MP4 that tells you that, hey, this is to everybody that wants to read it, that this is this is AI-generated content. So this is a final look to our processing pipeline. So you need an awesome model that is in case of Moviegen, but you also need to add a lot more stuff if you want to deliver that experience at scale. So pre-processing pipeline, adapting the video to what the model needs, post-processing pipeline, reverting those conversions, plus adding this extra quality that we wanted our users to have. And obviously all the safety checks. Challenges, there is a lot of them, but I wanted to focus in two. So the first one is research to production. So again, Moviegen is an awesome model. It's an incredible, I would say, model that you send a video in a prompt and produces a video. But inside the lab, everything works. So basically, you have your pristine content. You have a relatively small set of test videos, and you can fine-tune the model to work with that. And also, you don't care about the codecs, about the resolution, because you set everything to exactly what you need. When you want to export or move that experience to billions of people, you need to take all of those details into account and do all of those adaptation pipelines and make sure that everything is tested at scale. And the second one, it's shocking to see that, but that's a question that Chi will be talking about that. But there's a question that it's very difficult to answer in this when you are developing with these AI models, Gen AI models. Is, are we improving? Because, okay, we have a video, we see a defect, we can work on the processing pipeline or on the model or on the fine-tuning, or we can tweak all the pipeline to make sure that that defect is gone. But are we improving? And definitely that video or that experience will be improved. But are changing that configuration or that applying that that change, are we breaking 10 other different user experiences? Remember, this has to work at scale. So basically, this reminds me, as I said at the very beginning, I'm all and off. This reminds me at the very beginning of the codec technology, the codec development, that there was a lot of people watching videos and with rate cars and putting some numbers. So this is basically how we know today that we are improving, because we are not there yet at the moment that we have been doing this parallel thinking with the video codecs. We don't have BIMF, we don't have SSAM that we can throw 10,000 assets and give a result that, hey, this on average, this change in this codec setting has been improved. Or in this case, on average, this change in the Moviegen model has improved the experience. So we are not there yet, but we are on the path to get there. And again, after, I think, so yeah, after that, we'll give a talk about that. So this has been a very good, very important challenge. So making sure that all the changes that we are making improve the average user experience or the final user experience. Okay, so this is all my talk. Thank you very much.